All right. So for packet one, we're starting off with a lot of your algebra review. So you're going to end up using distance formula and midpoint formula. So your midpoint formula is going to be the average of your 2 points. So x1 plus x2 over 2, and then big old comma right here, y1 plus y2 over 2. All right, so how much of this do you guys really want to go over? Because this is going to be kind of up to you. If we want to do one out of each section, we can. If we want to skip around and go to the ones that we know, we're like, yeah, I don't remember that at all. Let me know. And you can unmute yourself and chime in at any point. All right. So it looks like the first 5 problems are all, or at least 1 through 3, are all just going to be using distance formula and midpoint formula. Do we want to go over that? Yes or no?
Yes, just one.
Yeah.
Just one. Okay. Do you have one in mind?
Maybe 3.
So I mean,
3.
whatever works.
Yeah, they're all pretty similar. So if I look at number 3, all right, it says JK has got these endpoints. MN has these 2 other endpoints, and they want to see if they're congruent. So when I'm looking at this, I would go, okay, fine, JK, I'll do in red, MN, I'll do in green, and then I'm trying to figure out if they're congruent, so I need to use that distance formula. So giant square root, and I've got -5 minus -1, which makes it a +1, squared, plus 2 minus 10 squared. And remember, you guys can use your calculators, and I don't know if you have Android or not, but Android calculator or Android has an emulator for a TI-84, which does make life a little easier. So you can literally just type this in. So -5 plus 1 quantity squared plus 2 minus 10 quantity squared. And that gives me 8.944. All right, and then in green, I've got to do x's again and y's again. So I've got 1 minus 9 quantity squared plus -3 minus a -7, so that'll make it +7 squared. And again, we type it in. And I've got the same thing. So when it comes to actually looking at this and going over it, like on a quiz or a test, that's enough work for me to say, yes, they are congruent. All right. The other one I would look at is going to be 5. Let's actually do 4 and 5 real quick. Just because 4 is one of the ones where you have to work backwards. And I know when we did it back in September, people kind of struggled. But at least this way we can kind of see what's going on. All right, so for this one, you've got a midpoint, y, all right, and it's right here. All right, and then you've got one of the other endpoints. So I've got some x plus 11 divided by 2, and that needs to equal that 3 that I got over here. All right, so we're going to have to multiply the 2 up by the 3. So I've got x plus 11 equals 6. Subtract off 11 on both sides. So I get x equals -5. Now I'm only half done. So that's kind of the stinky part because you do need to find the entire coordinate, and that entire coordinate involves x and y. All right. So to solve for y, I've got y plus a negative 5 over 2 equals negative 1. All right, same exact setup. I'm going to multiply 2 by a negative 1. So I get y minus 5 equals negative 2. Add 5 to both sides. And I've got y equals 3. All right. So far, so good. Anybody like, how the crap did you do that? Where did all of that come from?
How the crap did you do that? Where'd that
Okay.
come from?
All right. So basically, you've got some segment xy, all right, or xz. So you've got some little line down here. Here is x, here is z. And then you've got y at the midpoint. Okay, so they give you what y is. They also give you z. The problem becomes, where do you find x? All right. So when you calculate midpoint, you're really taking the average of your two endpoints. So you would add those two x's together and then divide it by 2, and that should give you your midpoint. So if I know the midpoint is 3 right here, I'm going to take whatever the x coordinate is for this point, add it to the 11 that I've got, and then divide it by 2. And that should give me 3. Okay. Is that a little bit better? Not so much.
Yeah, that's better. Thank you.
Okay. Now, because you've got x and y coordinates, you have to do it twice. And that's where things become stupid, is because you've got to solve it for the x coordinate and then again for the y coordinate. So it just gets kind of tedious. You just have to make sure you do it for both. All right. Now for number 5, the one that they give us is, they give us a segment CE. And then they give you the midpoint as being D. And then they tell you, like, all right, CD is 9x minus 7. So this little chunk right here is 9x minus 7. And then from D to E is 3x plus 17. All right. So knowing that, I can say that because this is a midpoint, these two segments here are both the same. Yes? Yes? No? Kind of?
Yes, no, maybe so.
Yeah.
All right. So remember, anytime I'm talking about a midpoint, it's literally saying it is in the middle. All right. So if it's in the middle, it means this segment on this side is the same as this segment on this side. So knowing that it's a midpoint, and they will tell you like, hey, it's a midpoint, you're just going to take your two chunks and you're going to set them equal to each other. All right. Do we need to go over solving this, or are we okay on that part?
I'm pretty good at least.
Good
I
on
don't
that
know.
part.
Okay, we're good on that part. All right. Ready for the next page?
Yeah.
All right.
Are we moving to the back or the next page?
Yeah, so the back is classifying angles. So basically, when I say pages on my computer, each side of the page is its own page. All right, so for this one, it says classify the relationship between angles 1 and 2. So these are vertical angles. And that makes them congruent, okay? So for this one, this is 68, and then angle 2 over here is 112. And if I add those two together, I get 180 degrees. okay? So because of that, that makes these two supplementary. Because they add up to 180 degrees. All right, this one right here, these are called linear pairs. And those add to 180 degrees as well. And then this last one over here, these are complementary. And they add to 90. All right. Ready? So do we want to do these where I just set them up and you guys solve for X like we did in class?
Yes.
Okay, Ella says yes.
Yeah.
Madeline says yes. I will accept silence as a yes. Okay. So if I start with number 6, these two are vertical angles, which means they are congruent. Okay, so I know 6x plus 29 equals 8x minus 5. All right, for 7, those are a linear pair, so they make 180 degrees. So I've got 7x plus 23 plus 21x minus 11 equals 180. All right, you guys need any more time to copy that down? So for number 8, it says A and B are complementary angles. So look for these kind of key terms. Complementary means these two have to add up to being 90. So I've got 90 equals these two added together. All right, and then I would point out it doesn't say solve for X. It says find measure of angle A, so you need to plug back in. All right, and then for number 9, it says that these two are supplementary. So if they're supplementary, they have to add to equaling 180. Cole, why are you being so weird? All right. Ready to move on to parallel lines and transversals? My goal is in like an hour or a little extra to get you guys through like at least setting everything up so you guys can finish it. So that way on your own, you only have to spend about an hour on it. So that's the goal. All right, so for this one, it says use the diagram below to classify each of the angle pairs. All right, so it starts off with 1 and 3. 1 and 3 right here. These are corresponding. Hi, Cole. We see you. Yes, honey. Oh my God. Why are you so weird? I got nothing. All right, 5 and 4 are going to be out here and out here. All right, those are going to be alternate exterior angles. All right, and the way you know they're alternate is because one is on this side of your little transversal and the other one's on the opposite side. All right, 6 and 7 are same side interior. And then the last one is 3 and 6. So here and here. And those are alternate interior. Alrighty. All right. So, do you want to do number 11 together, or do you want to jump to 12 and 13?
Maybe
11
12 and
together.
13.
All right, Madeline said 12 and 13. Ella, what'd you say?
I asked for help on 11.
On 11? Okay. So here's the deal with 11 that I would really recommend. Like, I'm going to zoom this way in. I draw all over my pictures when I do these, remember? So they tell me that angle 9 is 76. And they also tell me that these 3 lines are parallel. So what I know is if this is 76, this one is 76, this one is 76. Boop, boop, boop. All right? All of those have to be 76. Vertical angles, high Cole. And then you've got same side interior, okay? Or corresponding, depending on how you're looking at it. All right, now everything else, I'm going to go through and circle in red.
Can't get myself off.
All right, so 180 minus 76 would make these all 104. And then it's literally, you just need to copy the numbers over here. Does that make sense?
Yeah, thank you.
All right, cool.
How do you do that?
How do you do what, Cole?
I always use my big ass face. I can't see you or like the problems.
So if you go over on the right, you should see little people in the upper right hand corner.
Oh, person. Okay, I got never mind.
And then you should be able to like thumbtack me so that you can see me. They also make an extension that pushes everything into grid view so you can see everybody, but at this point you don't really want to see everybody. You want to see what I'm doing over here. All right. So, Ella, you good on 11 now?
Yeah.
All right, cool. So do we want to go back to 12 and 13? We just set them up? No? Cole, you don't want me to set them up?
Well,
Oh, no. I was talking to Will.
do they just equal each other?
Yeah, so these two equal each other. These two add and equal 180 degrees. All right, so because these are same side interior, they're supplementary. These two, luckily, corresponding angles, set them equal to each other and be done.
All right, that makes sense.
All right. $14. All right, it says A and B are parallel, solve for X and Y. So we've got a couple of things that have to happen. The first one is going to be solving for X. All right, so you have to look and see what those relationships are. And these are alternate exterior, which means that they are congruent. So I've got 13X minus 27 equals 10X plus 6. Do you guys just want me to finish 14 and call it a day? Like, move on? Or do you want to actually try doing this on your own?
Hold on for a sec. Like,
okay.
Stop doing stuff.
Got it.
William, hey princess.
Like this?
You can't hear you.
Yes, I don't.
Your mic's too low.
All right, you're good.
All right. So when it comes to this one, you have to start off by solving for X before you can do anything else. So if I move my 10X over, I've got 3X minus 27 equals 6.
Galaxy, Martian, star, Luna, and jet.
Some of us got unmuted. All right, so I've got 3x equals, what is that, 33? So x is 11. Now that you know what this is, you have to plug it back in so that you can solve for y. All right, so I've got 10 times 11 plus 6. That is 110 plus 6. So that means this angle over here is 116. All right. So knowing that, I can say, all right, well then this chunk plus this equals 180. So 9y plus 19 plus 116 equals 180.
You don't be in it with me.
She said, homie, just watch.
I did say homie just watch, and Cole's mic's not muted, so we can all hear you.
Watch, look at my screen.
I don't even know how to get to the goddamn paper, though.
Cole, I'm going to mute you so you can yell at him for a second, okay?
All right.
Thank you.
I'll be myself. It's fine. I'll be myself.
All right. Are we okay solving for y on our own?
Yeah.
Yeah, we're good. All right. So, all right, it says use the diagram. All right. So this is going to be another fill-in one. I kind of want to leave that one so you guys can try it. Cole, I'm going to mute you for a second. Okay. So for 15, I would say kind of try that on your own, just because it is very similar to 11. But if all else fails, draw this figure on a separate sheet of paper, blow it up, and then start writing stuff in as you go through. All right. So topic 4 is talking parallel and perpendicular lines. All right, so graph, use rise over run. Don't forget zero slope and undefined slope. So remember, anytime you have zero slope, that's y equals a number by itself. And an undefined slope is going to be anytime you see x equals a number. All right, this is your horizontal line. And this is going to be your vertical line. All right, ordered pairs using the slope formula. All right, and then your equations are going to be y equals mx plus b. And nobody really likes standard form, but it's still a thing. The one I do want to give you that's not on here, and I'll scroll back up so you guys can see, is going to be what's called point slope form. All right, so what this does is you've got y minus y1 equals m times x minus x1. All right, where you've got x1, y1 in a point, and then you've got your slope. All right, and then literally all you're doing is you're plugging crap in. It's going to depend on what you're given. That makes life easier, but I personally stick with point slope form and slope intercept form because I tend to like those the best. All right, ready to go on to the next sheet?
Hold on.
Okay.
I have a question.
What do you got, Maggie?
Huh?
What do you got? I'm asking, what's your question?
Midpoint. Right. Wait, are we on the first page?
We're on the back side of the first page.
The angle relationships?
Yeah, we just finished the bottom of that page.
Oh. Okay, well then I'll ask you later. Oh, okay, wait. Can you scroll up really fast? Did we go over any of the questions?
Yeah, we already did. So how about when I'm done and I post the video, you just watch like that first 10 minutes and then we'll be good. All right.
Okay, hold on. Can I write this stuff in first? The topic 4. Okay, hold on.
Okay, hurry. All right, so when you are describing the slope of parallel lines, those two have the exact same slope. All right. Now, when it comes to perpendicular lines, this is going to be where you have what's called opposite reciprocal. All right, so opposite reciprocal is normally easier to describe in an example. So let's say your first slope is 2/5. All right, to make it
I'll be back in a
opposite
minute, I'm gonna
reciprocal. Cole, hang on, I gotta mute you, honey. Oh, or Cole just left the meeting. That works too. All right, so if I'm doing opposite reciprocal, it means whatever sign, positive or negative, when you go to do it, you flip it. So if this one's positive, my new one needs to be negative. The reciprocal part means you flip the fraction. So if it's 2/5, I'm going to flip it to being 5/2. All right.
Hold on.
No worries.
Why is it a -5?
So I always put my negative on the numerator of my fraction just out of habit because I tend to write really like close to that fraction line. So if I don't put it on top, I think it's part of the fraction line and that gets messy. You could put it on the bottom. It really doesn't matter. I just know I need them to be opposite, meaning one's got to be positive, the other one's got to be negative. All right.
So is like 2 negative in the first one?
No, the 2's positive in the first one. Both of them are positive. Okay, so think about it this way. A negative divided by a negative is still a positive, right? Yes?
Yeah.
Okay. So you can only have one negative sign for it to still be a negative fraction. So that's why I just put the 5 as the numerator as being negative. All right. So 16 and 17, they're asking you to give a parallel slope and a perpendicular slope. The easiest way to do this is literally just counting. You can be super lazy. There's really no math that needs to happen with this. All right, so I'm going down 1 over 1, 2, 3, 4. So it's literally down 1 over 4. And then perpendicular would be flipping it. So 4 over 1. And then if the top one is negative, what's this bottom one need to be?
Positive.
Positive. All
Wait,
right.
are we talking about Oh, okay.
Yeah. No, you're good. All right. And then same thing with this one. This one is an undefined slope, so it's literally undefined. And then the perpendicular slope would be 0.
For 16,
Yeah.
wouldn't the parallels are we able to flip that or no?
So you're flipping it when you're writing your perpendicular, but when I'm talking parallel, I'm just asking for what is the slope of this current line.
Oh, okay.
All right. So 18, 19, 20, you're just playing with the slope formula quite a bit. All right, so these are all slope formula problems. And it's literally just plug it in. Are they the same? Are they opposite reciprocal? Or are they neither? That's it. All right. So if I scroll down here and I start looking at these, all right, it's just asking, can you determine if these are parallel, perpendicular, or neither again? The easiest way to do this is to reorder and get them into slope-intercept form. All right. So I'll show you on number 23. So I'll start with this one right here. So 4x plus 3y equals 9. Your goal is to get y on its own. And fractions, when it comes to slopes, are still acceptable. So make sure that you don't like try to get rid of this because that's still a legit number. So it's negative 4/3 x plus 3. And then for this one,
So you can't. Oh, sorry.
go ahead.
I got a question, Mason.
Go ahead.
So you can't do, since the 9 and the negative 4x, you have to put those together? You have to add them?
Yeah, you're going to add them
Like-
because the 9 doesn't have a sign, so we're assuming it's positive. But you can't actually
Okay.
combine them because one's got an x and the other one doesn't.
Okay.
All right, so this one over here, I've got 3x plus 4y equals 36. Same steps. And then divide by 4. All right, so now that I've got those reordered, these are my two slopes. All right, now they're not the exact same, so they're not parallel. All right, they're reciprocals, but they're both negative. All right, see how both negative? That means they're not perpendicular either. So this is a neither because it doesn't fit into either of those two categories.
So the reciprocal would be if they were both positive, they would be the same.
So the reciprocal when it comes to a fraction just means flipping it. The opposite part means one slope is positive, one slope is negative. Does that make sense?
Oh yeah, so if it was negative 4/3 and positive 3/4, it would be reciprocal.
Yeah, it'd be opposite reciprocal. We could say it's perpendicular. It's that one stupid negative right here that's screwing it all up. All right.
Oh, okay. Thank you.
Yep. All right. 24 is easy peasy. There's no slopes involved. These two should just be parallel. If they're both y equals a number and y equals a number, they're both flat, so they're both going to be parallel. All right. Ready for the back page?
What's the next page? I only have up to 24 printed.
Okay. So the next page, it looks like, starts packet 2. We trucked through that pretty quick. So Madeline, I can still go through it and you can just kind of watch along and then print it and then.
Oh, I have all of them printed.
Oh, okay, cool. So yeah, this is just packet number 2. So it's starting into counter examples and then conjunction, all that jazz. Inverse, converse, contrapositive, biconditionals.
Oh,
This was the one that you guys really liked. So it's up to you if you guys want to do this with notes or if you want to jump to packet 3 and do all the triangle stuff.
Can we start with the the conjunction, that stuff?
Yep.
I don't have the notes for that anymore, so I don't know.
We can do that. The notes are all still on Google
do for it?
Classroom, so you can save all of that if you need access to it. But, all right, let me get back here. All right, so counterexamples are literally just providing a time when this is false. So the easiest way I always explain this is when you guys say, everybody else gets to do it, all I have to do is find one person who doesn't and be like, I win, you lose. All right, so these are kind of easy peasy because all I need are a couple examples where it doesn't work. So like for number 1, a multiple of 4 would be 4, 8, 12, 16, 20, blah, blah, blah. Well, 12 is not a multiple of 8. All right. And then base angles for isosceles. Honestly, I would kind of save that one. This one's true anyway, but you're going to want to refresh on some of the triangle stuff because you're going to be kind of shocked. The amount of stuff we actually learned is way more than you think it is. All right. So let's scroll down to compound statements because I guarantee this is the stuff that's really going to mess your day up. All right, conjunction is written like this, and it is read as P and Q. All right, and it's only true when both of the statements are true. This one is P or Q, and it's true when at least one. All right, so as I'm looking at this, all right, it gives you a whole bunch of statements to go off of below it. So Las Vegas is in California. That's my first one. And that I know for sure is false. It's in Nevada. All right, opposite angles of a parallelogram are congruent. This one is true. Okay, so when it's written P and then disjunction, so a V, and then Q, this is saying Las Vegas is in California, or opposite angles all right, so this one is false or this one is true. All right, so because it says an or, as long as one of those statements is true, we would write a true down here. Okay. The one I do kind of want to look at are these squigglies. Do you guys remember what the squigglies mean?
Not.
Yes, they mean not. All right, so let's scroll down. We'll do number
So
8.
it's like-
All right, so this is saying Vegas is not in Cali. All right, and because it's up like this is and, right? Looks like a capital A. And opposite angles, blah, 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 are congruent. All right, so Vegas is not in California. That's now true, correct? And opposite angles of a parallelogram are congruent. This is also true. So because they're both true and it is an and, we can write true down here. All right. Ready to flip?
Yeah.
All right. So on the back, we're starting with more conditional statements and stuff. So let me fill this in real quick. So I've got P, then Q. All right. So for this one, I'm going to go through and do 9 and 10, and then I'll leave you converse and contrapositive so that way you can practice them on your own. So it says P is a line is tangent to a circle, and then Q is it is perpendicular to the radius. So for the original conditional, literally you're just taking if, and then you're slapping whatever this is right behind it. A line and then we go, then Q. It is perpendicular to the radius. Do you guys remember that this sign is perpendicular? The upside down T.
Yeah.
Okay. All right, so this is true because it's the definition of a tangent line to a circle. All right, now the inverse is just saying put knots in. Okay, so if a line is not tangent, to a circle, then it's not going to be perpendicular to the radius. This one's going to be false because do you guys just want to trust me on it, or do you want me to actually draw why it's false?
Just like go over it. Yeah, go over it.
Okay.
Like why?
Just
So-
explain it real quick.
So essentially, I can have, let me refresh you on tangent lines real quick. All right, so if you've got a circle, right here, and then I've got this bad boy right here. This is my radius, yes? Now, if I have a tangent line, and I'm going to do this in a different color just so you guys can kind of see it. If this is my tangent line, it has to create a right angle right here. That is the only way this is going to be tangent. Correct? Now, the one we just wrote says,
Yes.
if a line is not tangent to the circle, then it can't be perpendicular to the radius. Now, here's the problem. I can actually create a line right here through the center of the circle that is still perpendicular to the radius, but it's not tangent. So that's got a single counter example that would prove it false. Okay. And this would be the diameter.
Wait, so it's it's perpendicular to the radius, but
Mhm.
not the tangent. Is that what you said?
Right. So
Okay.
I'm saying it's still perpendicular, but it's not a tangent line. All right. So because it doesn't fit both of those criteria, it's going to be false. Right. So I think we've already got that filled in with false. All right. Biconditional statements. This is going to be written as P double arrows Q, and it's read as P if and only if. Q. All right, so the statement they give us is, it is Halloween if and only if it is October. True or false?
True.
True.
So are there any other days in October that are not Halloween?
No. Wait. Yeah.
Yeah. So that's what's, yeah, it's any other day in October. Okay, so this is going to end up being false, and here's why. All right, so if it is Halloween, then it's October, right? Now this one is true. The problem comes in with the converse. So the converse means I'm just going to flip the order of them. Okay, so now it's going to be, if it's October, then it's Halloween. This one's false. That's what screws up your whole biconditional, is because one of those is false.
So, like for the first one, it is Halloween if and only if it's October.
Right.
Does that mean like that's false because it's not saying it's October 31st?
Right. That's exactly it.
All right.
It could be October 12th. Right?
Yeah.
It's still October, but it's not Halloween. So that's doesn't work.
Okay. Thank you.
Yep. All right. Ready for the next page?
How many pages do you want us to have done a day?
So here's kind of what I'm thinking. Because you guys have 7 reviews for geometry. I would kind of like to do 1, 2, and 3 this week. So then you've got 2 next week and 2 the week after. That way, we'll have definitely hit everything before you guys take the final. Sorry, the hiccups all of a sudden.
Okay.
I think we could probably knock out 1 and 2 today, and then they would be due by Thursday. And then Friday, we'll meet again to go over review number 3, and then that one won't be due until like Monday of the next week. Does that make sense? And here's the thing, like I'm still being super flexible on if it's late or anything like that, because obviously crap happens, so you can't get 2 of them done, even though like we've set up most of them and we're completing a lot of them. We do want to make sure that we're still getting through everything, and I want to make sure you're taking the time to actually do it. So if you only get 1 of them done by Thursday, not the end of the world. Answer your question, Ella?
So I've missed like 2 weeks because I've been really sick.
All right, so the next page, we've got another biconditional practice, but we've got laws of detachment and law of syllogism. All right, so law of detachment is saying if P, then Q, and then P happens, all right, then we can say for sure Q will follow, okay? Law of syllogism says if P, then Q, and then if Q, then R, we can jump straight to the end and saying P.
What are those dots?
The dots mean therefore.
Oh,
Okay. So I kind of want to jump to like 17, 18, and 19 so we can practice with that a little bit and make sure we're okay with which is law of detachment, which one's law of syllogism. So for 17, it says, if Mark gets an A in math, then he will make honor roll. If Mark makes honor roll, then his mother will buy him a new skateboard. Replace skateboard with car or new iPhone, whatever you want. So the conclusion would be, if Mark gets an A, then he gets a new skateboard. All right. What you're looking for is an area where this stuff gets crossed out. Something of overlap disappears. Okay. So that's what's going to make it law of syllogism. Because if he gets an A, then he makes honor roll. If he makes honor roll, then he gets a new skateboard. You're getting rid of the honor roll part, because let's be honest, Mark really doesn't care if he gets honor roll. Mark just really wants a new skateboard. All right, ready for 18? If a number is a whole number, then it is an integer. If a number is an integer, then it's also a rational number. All right. So this is going to harken way back to like algebra and like, do you know where your numbers belong? I can tell you right now, this one's invalid. All right. So if a number is a whole number, that means like 0, 1, 2, 3, blah, 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 blah. All right. These all belong in integers. Okay. Integers are where you add in your positives or your negatives, really. So like -3, -2, blah, blah, blah. But it still also includes all of those whole numbers. All right. The next line down says if it's an integer. Well, guess what? If I give you -6, all right, that's still going to be a rational number because this belongs in here. Correct? Thumbs up if we're
Yeah.
good. Okay, cool. All right. Now here's the problem. Again, if I start with if it's a whole number, then it's a rational. All right. I can make that jump. But if you look down here at the conclusion, it says if it's a rational number, then it's a whole number. They flip-flopped the order on that. Okay. So because they screwed up the order, then we can't make any conclusions about it. All right. All right, for 19. If a number is a multiple of 6, then it is divisible by 3. All right, you're given that 15 is not a multiple of 6. All right, that's true, right? The conclusion is 15 is not divisible by 3. Is that true or false?
False.
False. Okay. So this is going to be invalid again. If they kept it in the same order with the same like truth, so like it is a multiple of 6, then it is divisible by 3. See how they added in those knots? This is going to mess up your whole day.
so wait, if they put in knots, it's invalid?
Not necessarily it is going to be invalid, but it's going to mess everything up. Like, you're going to have to be extra careful and check it. Okay. So if they said,
Oh,
if a number is a
okay.
multiple of 6, then it's divisible by 3. And then I give you 24 is a multiple of 6. Is that true?
Yeah.
All right. Is 24 divisible by 3? It is. 8. 24 divided by
Oh.
3 is 8.
Duh.
I know we haven't actually been in school for 2 months, so I'll let it slide. All right.
That's true.
I mean, let's be real. All right. So, ready for this last page?
Yeah.
All right. So, this one right here is law of detachment. All right. So it says, if a chord passes through a circle, the center of a circle, then its diameter. Well, guess what? You have a chord that passes through the center of a circle, right? So the if statement happens. That means this has to be a diameter. So this is law of detachment. All right. Last little bit is Venn diagrams. And we didn't do Venn diagrams in class because, let's be honest, you've been kind of hit with them a lot in social studies. But I just kind of want to bring it up because you may see problems like it on your final, and it's literally logic. Okay, so draw a Venn diagram to represent the relationship. No skew lines are parallel. So that means you've got 2 separate circles. This one's going to have skew. This one's going to have parallel. All right, when they say no, it means they literally have no overlap. All right, the next one says all roses are flowers. Okay, so here are my roses. If I say all of them, it means they all belong in. That's a terrible circle. I'm really sorry. It looks like a lima bean. All right.
It's okay. Mine looks like a lima bean too.
Who actually draws circles like freehand? Let's be honest. All right. Last part is some prime numbers are odd. So anytime you have a sum problem, oh wait, I can do this and be super lazy. Haha.
That's cheating.
Not cheating. I'm using my resources. All right, so here's prime. Here's your odd numbers. When I say some of them, it means this little chunk right here is going to be the area of overlap. All right, last little bit, and then I will set you guys free. All right, so the Venn diagram below shows the relationship between students involved in pep band, marching band, and chorus. Okay, determine if each statement is true or false. So it says up first, some of the students that are in marching band are in chorus. Okay, so yes, that is true because I have this little area right here of overlap where they could be involved in marching band and chorus. All right. 25 says all of the students that are in marching band are in pep band. Now, is that true? Maggie says no.
No.
Yep, Ella says no. Nope, that's not true. All right. The next one says no students in pep band, which is over here, are in chorus. That is true. All right. And then 27, some of the students in pep band are in pep band, marching band, and chorus. Do you have any area of overlap with the 3? All 3?
No.
No. All right. So that is false. And then this bottom one is going to be all counting stuff. Okay. So I think we're done. We finished